East China Sea. The RC-135W Rivet joint, a Boeing 707 derivative, operated by Air Mobility Command on behalf of the intelligence community, crewed by 35 personnel, including signals intelligence specialists who do not discuss their work in any form that lacks the appropriate clearances, has been on station for 3 hours and 19 minutes. It is flying a racetrack pattern in international airspace at 31,000 feet. The collection equipment running in the back of the aircraft is characterizing electromagnetic emissions across a frequency range that the aircraft's own operators are not permitted to describe in unclassified settings. What can be said in unclassified settings is that the RC-135W is very good at its job, that it has been flying variants of this mission for decades, and that the collection product it generates is among the most valuable intelligence the U.S. government produces on a regular basis. The PLAAF controller at the air defense sector on the Shandong coast has had the RC-135W on his display since it entered his coverage arc. He has a J-112 ship on ground alert, the J-11B, Shenyang's unlicensed reverse-engineered derivative of the Russian Su-27 flanker, a large twin-engine air superiority fighter with a radar cross-section that could charitably be described as prominent, and a flight performance envelope that in the original flanker design was genuinely impressive in 1977 when the prototype first flew. The J-11B's relationship to the original Su-27 is a story worth a moment's attention because it illuminates something about the aircraft that will matter later in this account. Russia sold China the Su-27 under a license agreement that included manufacturing rights and technical documentation. China built the aircraft as the J-11A under that license. Then, over the course of the program, China gradually substituted domestic components for Russian ones, avionics, radar, engines, in a process that Russia observed with increasing displeasure, eventually concluding that China was producing an unlicensed derivative of the design and refusing further technology cooperation. China disagreed with this characterization and continued production. The resulting aircraft is the J-11B, a Chinese-built flanker variant with Chinese avionics, Chinese radar, and Chinese engines, whose relationship to the original Russian design is close enough that the engineering heritage is obvious and distinct enough that Russia will not acknowledge it as licensed. The J-11B is a capable aircraft within the envelope its design defines. Its airframe agility, the flanker family was designed around a relaxed stability configuration that gives it exceptional pitch authority, is genuine. Its radar, the Type 1473, is a mechanically scanned pulse Doppler set that is the generation before active electronically scanned arrays. It works. It is not cutting edge in 2025, but it works. The engines, WS-10A turbofans, have had a development history that the PLAAF's maintenance logs would describe as eventful, and that Western analysts would describe as characterized by reliability challenges that the program has been progressively addressing over 15 years of production. The J-11 pilot climbing toward the RC-135W's altitude has approximately 240 flight hours per year, more than some PLAAF pilots, less than his U.S. Air Force counterpart, sufficient to be proficient in the aircraft's standard operational parameters. He is going to demonstrate something this morning that will require him to operate near the edges of those parameters, which is relevant context. The RC-135W crew knew the J-11S were airborne before the PLAAF controller had finished his launch authorization. This is the central dynamic in every story involving U.S. reconnaissance aircraft in contested airspace. The platform being intercepted is, in its operational category, a collection machine, and the intercepting aircraft is the most productive thing that has appeared in its collection environment all morning. The J-11's radar came online during its climb. The RC-135W suite had it characterized before it reached 20,000 feet. The intercept was logged not as a threat but as an opportunity. The specific opportunity of a PLAAF air superiority fighter operating its fire control radar at known range and geometry while all of the RC-135W's collection equipment was pointed in its direction. The first J-11 arrived at the RC-135W's altitude and executed the standard intercept approach, coming up from below and behind, moving to a wing position, conducting a visual inspection of the reconnaissance aircraft at close range. This is normal. This is the intercept playbook that every Air Force with jets and a reconnaissance aircraft to be annoyed by has been running since the 1950s. The RC-135W crew noted the intercept, logged the aircraft type, and continued their collection mission. The collection mission was at this point producing excellent data on the J-11B's Type 1473 radar in operational mode, standard intercept, standard documentation, standard collection. Then the second J-11 pilot did something that was not in the standard intercept playbook. He executed a barrel roll. A barrel roll is an aerobatic maneuver in which an aircraft simultaneously rolls and pulls, describing a helical path through the air while nominally maintaining forward progress. It is a maneuver that pilots practice, that air show performers execute, and that a combat aircraft might use in a close-range maneuvering engagement to control the energy state of a fight. It is not a maneuver that belongs anywhere near an aircraft you are intercepting, particularly when the aircraft you are intercepting is a Boeing 707 derivative that is approximately twice the size of your fighter and has zero ability to take evasive action without risking structural limits that were established for a transport aircraft rather than a combat jet. The J-11 pilot executed the barrel roll at a range from the RC-135W that the after-action report would describe as approximately 20 meters at the closest point of the maneuver. 20 meters. Between a fighter aircraft executing an aerobatic maneuver and a 35-person reconnaissance aircraft operating in international airspace. 20 meters is the distance from one end of a bus to the other. It is the length of two full-size pickup trucks parked bumper to bumper. It is between a maneuvering fighter and an unarmed reconnaissance aircraft in flight, a number that the aviation safety community would classify as a near miss by a margin that leaves very little room for discussion about whether the classification is warranted. For the 35 people on board the RC-135W, those 8 seconds represented the kind of operational moment that training cannot fully prepare for. The correct procedure, maintain heading, maintain altitude, document everything, was executed. The pilot on the other side had sufficient professional judgment to complete the maneuver cleanly. The closest point of approach was 20 meters, not 0. The distinction between 20 meters and 0 is, from the perspective of the crew, everything. It is also, from the perspective of aviation safety, a margin that the relevant protocols exist specifically to keep substantially wider than 20 meters. 20 meters is not that distance. 20 meters is the margin at which a variation in airspeed, a turbulence encounter, or a fraction of a degree of heading error closes the gap in a way that protocols exist to prevent. Here is the genuine operational weight of those 20 meters, stated precisely. The RC-135W is operating under international aviation regulations. It is in international airspace, it is unarmed, its crew is conducting a lawful mission. The J-11 that just rolled through 20 meters of clearance from its fuselage is a military aircraft conducting an intercept in international airspace. Also legal, also within the framework of established state behavior. What is not legal, not established state behavior, and not within any professional aviation standard that any Air Force formally acknowledges is executing an aerobatic maneuver at 20 meters from another aircraft. The PLAAF's own flight safety regulations prohibit unsafe approaches to intercepted aircraft. The relevant international protocols for military intercepts specify that intercepting aircraft must maintain safe distance at all times. 20 meters during a barrel roll is not safe distance. It is the margin at which a slight variation in airspeed, a momentary turbulence encounter, or a fraction of a degree of heading error produces a collision. The RC-135W crew felt the turbulence from the J-11's wingtip vortices as the aircraft completed its roll. This is in the mission report. The wash from a J-11's wingtip at 20 meters is a physical event that the crew of a large reconnaissance aircraft experiences as a movement of their platform. The mission report notes it with the specific language of professionals who are trained to document what occurs and leave the editorial characterization to the after-action process. The after-action process characterized it clearly. Now let us discuss what the RC-135W's collection suite was doing during the barrel roll and the intercept period that surrounded it, because the barrel roll was the visible drama and the collection was the operational substance. The J-11B's Type 1473 radar in operational mode, which it was running continuously from intercept approach through the post-roll repositioning, was being characterized by the RC-135W's suite in a collection geometry that is unusual to achieve. At close intercept range, the signal power arriving at the RC-135W's receivers from the J-11's radar is substantially higher than at typical surveillance ranges. The pulse characteristics that are estimated at distance are measured at proximity. The antenna side lobe structure, WSOM, which tells analysts something about the physical design of the array, is resolved rather than inferred. During the barrel roll itself, the geometry between the J-11's radar and the RC-135W changed continuously. The roll rotated the aircraft through 360 degrees of orientation relative to the reconnaissance platform, exposing different aspects of the radar antenna to the collection system in rapid sequence. This is not a collection geometry that any planned mission profile would generate. It is the collection geometry of a J-11 pilot executing an aerobatic maneuver 20 meters from the thing that was collecting him. The RC-135W's suite captured the Type 1473's emission profile from angles of incidence that would require multiple separate collection missions to replicate under controlled conditions. The roll provided, in approximately 8 seconds of aerobatic maneuvering, a 360-degree antenna pattern characterization that the signals intelligence community will be analyzing for months. The pilot thought he was being impressive. He was being informative. The WS-10A engines produced a thermal signature during the maneuver that the RC-135W's infrared collection equipment characterized in detail. High power settings, high angle of attack, the specific thermal bloom of a Chinese-built turbofan under combat maneuvering conditions. This is data that supplements the radar characterization with a complete sensor fusion picture of the aircraft in an operationally realistic flight regime. Not a cruise flight, not a transit, a combat maneuver. The data from a combat maneuver is more operationally relevant than the data from a transit because it describes the aircraft in the conditions under which it would be used. The collection summary from the barrel roll segment alone is more operationally useful than the entire preceding 3 hours and 19 minutes of the racetrack mission. This is not a criticism of the racetrack mission. The racetrack generates consistent baseline collection that builds the cumulative picture over time. It is a statement about the specific value of observing a radar in combat maneuvering mode at close range from multiple simultaneous angles. Baseline collection tells you what a system does in cruise. The barrel roll told the RC-135W what the Type 1473 does when the pilot is flying an aggressive intercept at the edge of his maneuvering envelope. These are different operational conditions. They produce different data. The combat maneuvering data is the one that matters when the question being asked is what this aircraft does in a fight. The J-11's navigation lights configuration during the intercept, the radio communications between the pilot and his ground controller, the communications between the two J-11S during the intercept sequence, all captured. The communications were on military frequencies with encryption, but the traffic pattern provides the metadata that tells analysts how PLAAF fighter controller communications function during an intercept. The check-in frequency, the update cadence, the information format in the controller's calls, the pilot's acknowledgement protocol. This is the organizational communication signature of a PLAAF fighter pair conducting an intercept. It joins the database entry for the J-11B radar characterization, the WS-10A thermal profile, and the 360-degree antenna pattern produced by the barrel roll. The collection product from this morning's intercept exceeds the collection product from a typical week of racetrack missions. The second J-11 repositioned after the roll and took a standard wing position. The first J-11 had maintained its wing position throughout. Both aircraft escorted the RC-135W for approximately 40 minutes before breaking off and returning to their base. The RC-135W completed its racetrack and returned to base on schedule. The mission debrief at the appropriate facility took 3 hours. The intelligence summary took the rest of the day. It was distributed to the relevant recipients, who found several sections of it significantly more detailed than previous characterizations of the J-11B's operational parameters. The RC-135W crew filed their incident report under the established protocol for unsafe intercepts. The report documented the barrel roll, the estimated closest point of approach, the turbulence from the wingtip vortices, and the crew's assessment of the risk created by the maneuver. The report was factual, precise, and written with the professional restraint of people who are trained to document rather than editorialize. The diplomatic channel received a formal protest from the U.S. government regarding the unsafe intercept. The protest cited the barrel roll, the 20-meter closest point of approach, and the applicable international protocols for professional military intercept procedures. It requested that the PLAAF ensure its pilots adhere to established safety standards. The Chinese Foreign Ministry response described the J-11S as having conducted a professional and lawful intercept of an American reconnaissance aircraft illegally operating in Chinese airspace. The response did not address the barrel roll specifically. It stated that China's military activities in its own airspace were lawful, and that the U.S. side should quote the RC-135W was 41 nautical miles from the nearest point of the Chinese coast when the barrel roll occurred. The flight plan was filed with appropriate authorities. The airspace was international. These facts are in the mission record with the precision that GPS timestamp navigation logs provide. The Foreign Ministry's response did not cite the GPS record. The GPS record is in the archive. Now, the economics of this morning, because the economic structure of this encounter has a dimension that distinguishes it from the others in this series. The PLAAF invested in 2 J-11B sortie costs: the ground alert crew time, the controller's shift, and the communication and support infrastructure for the intercept. These are real costs. They produced, from the PLAAF's perspective, a demonstration of willingness to intercept U.S. reconnaissance aircraft at close range, a message that the PLAAF has been sending with increasing emphasis in recent years as a component of its broader A2/AD communication posture. The U.S. invested in the RC-135W's mission cost, a substantial number per flight hour for a platform of its sophistication and crew size. The mission was planned to generate collection from a racetrack in international airspace. The barrel roll generated, as a byproduct of the PLAAF's unsafe intercept, a collection product that substantially exceeded the planned mission's value. The PLAAF spent money to send a message. The RC-135W collected the messenger. One additional note on the economics that the U.S. Air Force did not anticipate and the PLAAF did not intend: the diplomatic protest and the resulting exchange created a public record of the barrel roll incident that has been cited in subsequent discussions of PLAAF intercept behavior, contributing to a body of documented incidents that informs both allied partner consultations and future rules of engagement development. The PLAAF's unsafe intercept became, through the protest and response cycle, a data point in the international record of Chinese military aviation behavior. Data points in the international record of Chinese military aviation behavior are collected by people who compile them into assessments that inform policy, and policy that shapes the diplomatic and operational environment in which the PLAAF operates. The barrel roll that the J-11 pilot executed in 20 meters of clearance from the RC-135W is in that record, precisely documented, permanently filed. He was probably proud of the maneuver. It was technically skilled flying. The flanker airframe, even in its J-11B derivative, has the agility to execute a clean barrel roll at close range, and doing so required genuine competence. The collection product it generated for the RC-135W suite was also technically skilled. In a different and more useful way, Chinese state media covered the morning's events by afternoon. The coverage described PLAAF fighters conducting professional interceptions of U.S. military aircraft illegally operating in China's airspace, demonstrating the Chinese military's firm will and strong ability to safeguard national sovereignty. The footage showed J-11 fighters on the flight line, intercepting aircraft in generic archival footage, and voiceover describing the PLAAF's commitment to defending Chinese airspace from what the broadcast described as deliberate U.S. provocations. The broadcast did not describe the barrel roll. It did not describe 20 meters. It did not describe the wingtip vortex turbulence that the RC-135W crew noted in the mission report. It did not address the 360-degree antenna pattern characterization that the maneuver had produced, or the WS-10A thermal profile at combat power, or the communications metadata that had characterized the PLAAF's Intercept coordination protocol. State media is produced from available material. The available material was the PLAAF's preferred narrative about the morning. The unavailable material was in the RC-135W's collection summary and the intelligence archive where the Type 1473's full operational profile now sits, updated, comprehensive, and actionable. The RC-135W returned to base, the crew debriefed, the mission summary was written, the J-11 pilot returned to his base. He presumably filed his mission report as a successful intercept of a U.S. reconnaissance aircraft in Chinese airspace. Both accounts are in records that will not be compared in any venue accessible to either crew. In the intelligence archive, the barrel roll is a timestamp, a collection geometry, and a 360-degree antenna pattern characterization that the signals intelligence analysts who received the summary described in the assessment that went to their supervisors as the most complete Type 1473 radar profile collected since the aircraft entered service. 20 meters. 8 seconds of aerobatic maneuvering, the most useful 8 seconds in the mission. Bye for now.